Welcome to our notes on dilations. So we're still talking about transformations, but now we're talking about transformations where the shape changes size. So remember, a dilation, it can be a reduction or an enlargement, but the key idea is the change is proportional. All right, so that's step one. All right, now scale factor, you've used that before. Remember, that's the ratio of the sides. Okay, well, how are we going to use scale factor for dilation? We're always going to compare new to old, or image on top, pre-image on bottom. Okay, so how are we going to know if it's an enlargement? Well, if that scale factor, I'll just put S, if that's greater than 1. So when I divide new by old, if that's greater than 1, it's an enlargement. All right, now if the scale factor is less than 1, or basically between 0 and 1, we know it's a reduction. All right, so less than 1, really, it's a reduction. Greater than 1, it is an enlargement. So let's look at our first example here. All right, if I want to find the scale factor of these two shapes, remember we want to compare corresponding sides. So I'm going to compare AB prime to AB, because remember we want to compare new to old. So what is the value of AB prime? That's 12. What's the value of AB? It's 4. So we want to reduce this. So this has a scale factor of 3. So it is an enlargement because it's greater than 1. And you can see in the picture, there's our pre-image without the tick marks. Here's our new image. It got bigger, so it's an enlargement. All right, notation. Let's do that real quick so you guys know what this looks like. All right, notation for dilation. They're going to put a capital D for dilation. They're going to put this T here. All right, they're going to put a comma. They'll put a number. Oops, sorry, the number's a little lower than that, subscript. And then they're going to put a shape. All right, in this case, we'll just call it ABC. So this point right here, that's your center. All right, the letter is the center of dilation. And this right here is your scale factor. So obviously it's 3, so that's going to be enlargement. And then this is the object that you're dilating. Okay, so there's the notation. Now, a couple quick examples. We'll get to we'll get to some more here. All right, determine if each of the following are enlargements or reductions. Well, you want to look at tick marks. All right, tick marks. So that's our new. This shape is our new. Here's our original. So it got smaller. That's obviously a reduction. All right, this one they just give us the notation. Remember, the key thing right here is there's our scale factor, greater than 1. So that is an enlargement. That's how easy it is. Now, when we dilate objects, this little diagram here shows that the center of dilation can be inside, outside the figure, or it actually could, or excuse me, on one of the figures, all right, or it could be actually outside the figure. So just kind of depends. Now, the thing I want you guys to notice is, notice that all of the straight lines, all right, I'll kind of put that here. Notice, all right, straight lines between letters of new and old. I'll just put, because I don't, instead of image and, all right, so if I look at A and A prime, straight line to the center of dilation. B to B prime, straight line to the center of dilation. Works on everyone. A to A prime here, whether it's on, straight line to the center of dilation. C to C prime, straight line. Even if it's outside, here's A prime to A. B prime to B, straight line to the center of dilation. That's going to be key. All right, that idea of a straight line. Now let's get to some examples. All right, we'll do example 1, outside. All right, we're going to dilate this shape. We're going to make it bigger, and then we're going to make it smaller. Okay, so the key here when we're doing these is understanding slope. All right, from the center of dilation. So I'm going to do A to A prime first. All right, we'll do this one here in blue. All right, if I count the slope, it's rise over run. So I go up 1, 2, over 1, 2, 3. So the slope is 2/3. Since my dilation is 2, I need to do that twice from the center. So I do it once, up 2 over 3. I'm at A. Now I need to do it a second time. Up 1, 2, over 1, 2, 3. Here is my A prime. Do the same thing for B and C. Count the slope. The slope is up 1 over 1, 2, 3, 4. So I need to do that again. Up 1 over 1, 2, 3, 4. There's my B prime. We'll do the same thing for C. It's down 1 over 2. So negative 1 over 2. So I just need to do that again. Down 1 over 2. There's my C prime. When I connect the dots, you can see that the triangle doubled in size, and I can draw straight lines. Now 1/2, you just cut it in half. So if I'll do that in red here, the slope for A was 2/3. So half of the rise is 1, half of 3 is 1, 1.5. So here's my A prime, all right, because half of 3 is 1.5. B prime, we said it's up 1 over 4, so it's going to be up 1/2 over 1, 2. There's my B prime. C prime was down 1 over 2. Well, it's going to be down 1/2 over 1. There's my C prime. When I connect, you can see that triangle got half the size of the original. So it's all about the slope. Doesn't matter if it's inside the circle or inside the shape or on. If it's here's a quick example. We'll do this one's a double. So from here, it's up 1. It's 1. So we just got to double it. There's A prime. B's over 1. Just double it a second time. There's B prime. C's down 1, 2 over 1. Down 1, 2 over 1. There's my C prime. Then just connect. And there it is doubled. Now, if it's on, the center of the rotation was A here. All right, that's fine. That means A is not going to move. All right, but the other two will. We just count slope. We're going to double it. Down 1 over 1, down 1 over 1. There's our B prime. C, all right, from the center. Down 1, 2, 3 over 1. Down 1, 2, 3 over 1. You do it a second time. There's our C prime. And here is our new shape. Remember, straight lines from the new image to the old image through the center of dilation. There it is. Okay, last example, determining the center of dilation and the scale factor. It's really simple, all right? What you guys are going to do is you're looking for the intersection of all of the A prime, A to A prime, B to B prime, C to C prime. Oops, didn't need that comma right there, but there you go. All right, that'll give us the center. So what you want to do is here, you just want to draw a straight line, see where they all intersect. So when I draw a line from A to A prime, all right, looks something like that. B to B prime. All right, looks some. Oops, that one's a little high. I'll bring that down just a touch. There we go. That's how it should look. Oh, moved on me. Close. Oh, close enough. All right, and then we've got C to C prime. And I'll kind of come this way with it. Now, if I did this properly, you guys can see that the point of intersection is right here. All right, so our center of dilation, what is that ordered pair? That point is 0, 2. That would be our center of dilation. It's that easy. And then the scale factor, it's all about slope. So how do I get to A? It's A is right here. This is A prime is up here. So to get to A, it's up 1, 2 over 1, 2, 3. Up 1, 2 over 1, 2, 3. Since I had to do it twice, it's a scale factor of 2. And there you have it, our notes on dilations.